Welcome back. Now we're going to start a new section. This is going to be section 6 that starts on page 407 of the official SAT study guide. Let's get started with some problems. So let's see, this first problem. And the first problem, just so you know, they tend to be tricky but really fast problems. And sometimes they're just really easy and fast. But they tend to be problems that you should be able to get hopefully in a few seconds. So if your plan of attack immediately that tells you it'll take you 3 or 4 minutes, your plan of attack might be non-optimal. It may be correct, but non-optimal. So the first question is x plus 2 over x is equal to 5 plus 2 over 5. And I was actually just looking at this problem right before we started this video. And well, anyway, this is a pretty neat problem because this falls into the category of there's 2 plans of attacks here. One will take you some time and involves quadratics. The other plan of attack is ultra fast. So this is, they say, okay, if x plus 2 over x is equal to 5 plus 2 over 5, then x can equal which of the following? And they give some choices. They give the choice 1/5, they give the choice 4/5, they give the choice 1, 5 over 2, and 5, right? These are the choices they give. So if when you see this on an algebra test, your natural reaction is, well, let me solve for x. And so let's see, you would add 5 plus 2/5, you'd get some fraction there. What do you get? 27 over 5. You'd multiply both sides by x. You'd get x squared plus 2 is equal to 27 over 5x. You'd have a quadratic. You would want to factor that or use a quadratic equation, etc., etc., etc. That would take you some time. And considering this is the first problem, that's not going to be the plan of attack. So let me ask you, do you see a pattern here? Do these 2 sides look the same? Well, they kind of do, right? We have an x here, an x here. Well, we have a 2 here, right? We have a 2 in both places. We have a plus in both places. But the only difference is wherever I see an x on the left-hand side, I see a 5 on the right-hand side. So does something jump out at you? Well, sure. If I just replace x with 5, it's going to equal this, right? Because if I just put 5, x equals 5, you get 5 plus 2 over 5 is equal to 5 plus 2 over 5. So this is the answer. So it could have literally taken you about 2 seconds. And I have to admit, when I first looked at this, I was like, boy, they're putting the first question as a quadratic. And I said, that can't be the way. And I looked at it a little bit longer, about 3 seconds longer, and I said, oh, this is just pattern matching. Let's move on to the next question. Image, clear image, image, invert colors. Okay, so they have a right triangle here. Let me draw the right triangle. Right, not a wrong triangle, a right triangle. Well, you get the idea. Let me get the paint tool. I'll draw this edge now with my free hand, my shaky free hand. And they say this side is 2, this side is y, this side is x, and this, of course, is the hypotenuse. And they say in the right triangle above, if x is equal to 3, so they tell us x is equal to 3, what is the value of y? Well, this is just straight up Pythagorean theorem, right? This is the hypotenuse. Y is the hypotenuse. So y squared is going to equal this side, 2 squared, plus this side, 3 squared. So y squared is going to equal 4 plus 9. Y squared is going to equal 13. Y is equal to the square root of 13. And that is choice A. This was just straight up Pythagorean theorem, nothing tricky there. Just kind of got to chug through it. I'm assuming I didn't do something wrong. Well, anyway, let's assume that and then move forward. Image, clear image, invert colors. I will now switch colors for the sake of variety. Okay, number 3. Which of the following, okay, it says all numbers that are divisible by both 2 and 6 are also divisible by 4. Right. Okay, that's cool. Which of the following numbers can be used to show that the statement above is false? So they're saying all numbers that are divisible by both 2 and 6, so if divisible by 2 and 6, so this is what the statement is saying, then it means that you're going to be divisible by 4, right? So we want to prove that this statement is wrong. So what we have to find is some number that's divisible by 2 and 6 that's not divisible by 4. So it's not divisible by 4. And we could actually just look at the choices. They give us the choices: 4, 8, 12, 18, 24. Well, 4 isn't even divisible by 2 and 6, so that doesn't work. 8 isn't even divisible by 2 and 6, so that doesn't work. 12 is divisible by 2 and 6, but it's also divisible by 4. So it doesn't disprove this statement. So we can't say that. 18, well, sure, 18 is divisible by 2 and 6, right? Is it divisible by 4? No. So this is our answer. 18, the example 18 is an example of a number divisible by 2 and 6 and is not divisible by 4. So this proves that this is an incorrect statement. Number 4. Number 4. In the figure above, well, let me draw this figure above, and I will switch colors. This is my rectangle. And then there's going to be a circle. The circle. Oh, I have a shaky hand. The circle looks something like that. Oh, look at that. Okay. And then we have sides A. Oh, no, this is side B. B, A, C, and D. And it says in the figure above, the circle is tangent to sides B, BC, and AD. Tangent means it just touches at one point, right? Of the 8 by 12 rectangle ABCD. So they're saying this is an 8 by 12 rectangle, and if it approximately drawn as, well, we can assume that this is going to be the 8 side and that this is the 12 side because it's longer. What is the area of the circle? Well, what's the formula for area of the circle? It's area is equal to pi r squared, where r is the radius of the circle. So let's draw that radius of the circle. So the radius of the circle is going to be this line right here, right? This line. Well, there you go, right? That's the radius, which is half the diameter. What's the diameter? Well, the diameter is this whole length. So the diameter is 8, right? So the radius is going to be half of 8. So we know the radius is 4, and then we just use the formula. We know this is going to be 4 because this is also 4, right? This is also 4 because its side is 8. So we don't even use this top side could have been 12 billion units wide, and it wouldn't have mattered, right? So we know the radius is 4. So we say area is equal to pi times 4 squared. Area is equal to 16 pi. And that is choice A. Alright, the next problem looks like it's more involved, and I only have 2 minutes left in this video. So I will do it in the next video. I'll see you soon.